Hi, my name is David Choung, currently a fourth year human biology major.
Hello, my name is Justin Kim, and I'm also a fourth year human biology major. And the topic that we'll be discussing is exploring scarless wound healing and hair neogenesis in the nevus skin. So, skin is an essential barrier found in organisms that protect it from the environment. As such, it is exposed to constant weathering and damage, occasionally leading to the formation of scars. This poses an issue since scar tissue lacks many properties seen in healthy skin tissue. However, in a strain of mutant mice, when inducing a large enough cutaneous wound, pigmented hair is present, which is an indication of scar tissue that is more closely resembling healthy skin. And this is not observed in wild type strain of the mouse. Hair follicles undergo periodic growth. The growth phase is labeled anagen and the resting phase is labeled telogen. Previous studies within our lab have found a mutant strain of mouse labeled Tyre NRAS Q61K that is in an anagen hair cycle in a period of time in which a wild type mouse would be in telogen. And so with that being said, the goal of our experiment is to determine if this mutant mice expresses greater rate of wound closure and smaller scar formation, greater hair follicle count, or pigmentation in post-wounding experiments. Shown on the slide is a list of materials that we use to safely anesthetize the mouse, induce large cutaneous wounding using sterile technique, and collecting images of the scar tissue samples. And shown on the slide is a timeline of when large wounding was created, as well as images of when the wounds were taken.
So for our research, we first created a 1.8 by 1.8 centimeter wound on the back of the mice. Then we observed the healing of the wound and tracked the wound closure throughout the days. Post-wound day 28, we collected skin samples and performed oil red staining to see visibly their hair follicles. And then from there, we acquired images of both the epidermis and dermocyte through a microscope. And from those images, we collected scar size and counted the number of hair follicles. So from a sample size of 6 for both the wild type and the mutant mouse, we counted there to be a higher average amount of hair follicles in the wild type mouse than the mutant mouse. However, this difference was not significant looking at the values here. However, when observing the scar size area in both the epidermis and dermocyte on the mutant mouse, as shown in the data here, we found that the data to be significant when comparing the scar size area for both the mutant type and the wild type mice. From this data, moving on to our next steps, we will be focusing on shifting our focus from the number of hair follicles to the pigmented hairs and bleaching skin samples to acquire a clarified visual of dyed hair follicles.
Thank you.